We will now start using the bag of words model we created in a classifier for sentiment analysis of movie reviews. By the end of this video, you should be able to explain what sentiment analysis is, train a sentiment analysis classifier with NLTK, and check accuracy on training and test data of this model. So, what is sentiment analysis? The term refers to the activity of identifying attitude or emotion encoded in a body of text, like a product review or work of literature. Classification using machine learning is a technique used for sentiment models. In our notebook, we will build a predictor of sentiment using the movie review corpus. As you would remember, classification is a supervised activity and requires labels from a ground truth data. This is where we will take advantage of bag of words and the curated negative and positive reviews we downloaded. We will use our previously implemented bag of words function to create a positive or negative label for each review bag of words. We will use naive Bayes classifier for this task. Although we haven't reviewed naive Bayes before, it is a very simple classifier with a probabilistic approach to classification. What this means is that the relationships between the input features and the class labels is expressed as probabilities. So, given the input features for a sample, the probability for each class is estimated. The class with the highest probability then determines the label for the sample. Let's now switch to our notebook one last time to end with the sentiment classification task using naive Bayes from NLTK this time, not scikit-learn. We will now start preparing our inputs and label datasets for the classifier. So we are using, again, a naive Bayes classifier. We are lucky that the database is curated to separate positive and negative reviews, right? So we will use this as ground truth data and build two dictionaries as a bag of words for positive and negative reviews. So I'm going to quickly do that here. We have the negative features, build bag of words features filter. This is the function we've done before, we've created before. We are using that and giving the words with negative fields, and we'll have a label neg associated to that. For each file in negative fields, we'll build a bag of words and store that in negative features. So we can print that one record in this negative features. We'll see that there are a bunch of words for the reviews, for one review, and it's labeled negative. We can do the same thing for positive features and print one record for positive features. We can now see, for example, positive feature 6, the 6th review on that frame is positive. So now we have our two features, and remember we have 1,000 records in them. So for each of these, we'll have about 1,000 records with a positive label and about exactly 1,000 records with a negative record label. So now we will start using the naive Bayes classifier. Let's import that from, as you see here, this is not scikit-learn, this is NLTK classify, so it's the classifier that comes in NLTK. And remember, we had 1,000 records in them. We can use 80% of the data for classification in naive Bayes. When we provide the first 800 rows in each feature, it's 80%, right? 1,000 times 80%. So we'll store that number, 800, in a variable called split. And we'll use that split to slice the first 800 for training and the remaining 200 for testing later on. So what we are doing here is we are giving the naive Bayes classifier to build a classifier that we will call sentiment classifier. And we are using the naive Bayes classifier to train it with the first 800 positive features and the first 800 negative features. Remember, they had labels pos and neg. We created them like we see here. So the classifier will know what to do with it. So we create the sentiment classifier on the, oops, we need to create the split again. Don't forget to run each cell before you move on. We'll use the first 800 records for positive and negative reviews to create our classifier using naive Bayes classifier. We'll call that the sentiment classifier. So we'll now check the accuracy of the model we built. And this model is called, remember, sentiment classifier on training set. We'll use the classification's accuracy function. It's a utility of the classification. And we are giving that the classifier and what we've given to train it with the positive and negative features. Remember, we trained it. The model has already seen this data set. These are the training data sets. So what kind of accuracy you would expect? It should be high, right? Because the model has seen this data. And we see that it's about 98% accuracy. So it's good. It's normal. But how will the model behave on the 20% of the data it hasn't seen yet? Let's go and give that 20% now to the accuracy function. We are applying the sentiment classifier to predict the labels for the rest of the data. So these are our test data. And the accuracy of it, if we calculate it, is around 71%. A human, the estimated accuracy for a human is about 80%. So an accuracy of around 70% is a pretty good accuracy for such a simple model, considering, again, the human estimated human accuracy is about 80%. Remember, we had a large vocabulary, and the sentiment classifier used all the words. But which of those words gave us this high-ish accuracy? The sentiment classifier, the one that model we built, has a function. It says show most informative features. We can actually run that and see what words or what features in those reviews were most informative. If you look at this output, we'd see outstanding, insulting, vulnerable. These actually affected the outcome quite a bit. So we will stop here. Let's cut these to clean up our notebook. Well done. You're almost through week 8. We have one more lesson, then you'll move on with your projects.